So hello everyone and welcome back to another video. This video we will go through database optimization techniques. Before I start this video, before we proceed forward, I request you all to subscribe to this channel and enable notifications, as every week I will be uploading a video related to networking and types of networking and going in depth about networking, what basically is networking. So, and if you're wondering which tool I'm using to record all my videos, it's OBS Studio. It's completely free on Microsoft Store for PCs and laptops. I'll put the link down in the description so you guys can have a look. Proceeding onto the video. What is a database and why is it used? Now, when we say that a company has a database, we basically refer to it as an organized collection of data, typically which is stored electronically. It means that it is either stored on a PC, laptop or a server. Why? Because it allows for efficient storage, retrieval and management of information. Furthermore, it also enables organizations to access and analyze information effectively, providing a structured way to handle huge amounts of data, which would be difficult in Excel spreadsheet or simple file systems. Now, why does it provide a structured way? Now, we suppose we have a company. Its name is company X and it has around 1,000 users. The 1,000 users, they have their all data stored in the company database. The IT management or the IT head, if they want to pick out a user's data from it, they will prefer database. Why? Because it puts all the users database according to the chronological order that the IT head is providing. Now, there are a total of 10 different types of database optimization technique. First one is indexing, then vertical scaling, caching, sharding, replication, query optimization, connection pooling, vertical partitioning, denormalization and materialized views. So in this video we will be going through 5 of them, from indexing until replication. So this video will have 3 parts: indexing to replication, then replication to vertical partitioning, and then last vertical partitioning to materialized views. Moving on with the first method, that is indexing. So what is indexing? Basically, indexing is a technique that is used to speed up data retrieval by creating a separate data structure that stores pointers to the actual data rows. In simple terms, basically, if I have a table consisting of pointers, indexing will shift it to it will shift the data containing data in rows. So what is the structure of the index? Basically, we have a search key, that is the main key, and the data reference to which it's assigned a value. So this search key and data reference together is known as a single index. What are the benefits of indexing? When we say that the XYZ company has used indexing as one of the database optimization techniques, what are the benefits of it? Faster data retrieval, like if you have stored data somewhere, you can quickly access it without any hassle. Then reduced disk IO. Basically, disk IO is nothing but a short form of disk input and output. So it reduces the disk input and output, means that it reduces the amount of data which is inputted and outputted into and by the system. It also improves query performance. Basically, query performance is nothing but like you ask a question and how fast you get the response. That is query performance. Then it also has trade-offs. It increased storage space. Big optimization techniques like this take up most of the computer's space, which causes slower write operations because it's a very complex process. Moving on with the second, that's vertical scaling. So, what is vertical scaling? The name itself suggests vertical means straight in a straight line up, and scaling means magnifying something. So, basically, vertical scaling is nothing but increasing the capacity of a single database by adding many physical components that like CPU, RAM, storage. Basically, it's in simple terms, it's increasing the hardware of the existing database to handle more load as more and more data is entered. So, example, I have a database which has one CPU, 8 GB RAM, and 1 TB SSD. I vertical scale it to dual core CPU, 16 GB RAM, and 3 TB SSD. I further vertical scale that to quad core CPU. Dual core means 2 CPU, quad means 4 CPU, 32 GB RAM, and 5 TB SSD. So essentially, we are upgrading the first database. So basically, we are upgrading the first database to the second, and then is to the third. Then, sorry for that. What are the advantages? It has a simpler implementation technique. Then it's also potentially faster initial setup, as many huge things require what do we say, slow setup it has, but this vertical scaling has a faster initial setup. It also has lower initial cost, as the cost to implement that system is way less than the other systems. But nevertheless, we also have limitations. What are the limitations? There are hardware limitations. It can also be a single point of failure. Like if something goes wrong while upgrading, the whole system or server might crash. Cost can become prohibitive. Yes, this is one important point to remember, that when implementing vertical scaling to increase CPU, RAM, or storage, you need huge amounts of money or cash to upgrade, as all these components are not very cheap in the IT market. Also, it's not ideal for very large data sets or high traffics, as if there is a huge data set, sorry for that, you can't improve it. It will take a lot of time and lot of amounts of money. I hope we are good with vertical scaling. So we will move on to the third technique, which is caching. Now, I know some of you are new to these methods, and others might have heard it somewhere else. So caching is basically a technique that temporarily stores frequently accessed data in a faster storage location to reduce the load on primary database and improve response times. Basically, I'll explain you in simple terms. It's like when you open, suppose we take the example of YouTube. Okay, you open YouTube on your phone. YouTube has a database, and that database, what it does, it sends, first you type something, example like you search on YouTube for recipe for a latte. Latte is basically coffee. Then it searches on the database. If it finds a matching result, it sends it back to you. And if you frequently search, if continuously 2 days, 3 days, you're searching the same thing again and again, it will store that frequently accessed data as a cache, basically a faster storage location, where as soon as you enter the data, you can quickly get results. So that is as far as caching is concerned. Moving ahead, we have sharding. Yes, sharding, some of you might have heard. It's like basically shards. Like sharding is nothing but You partition a large database into smaller, more manageable tables or pieces called shards. So shards is like a common word if you guys play any games. Like suppose we look at an example of Minecraft. There we have what is known as shards. Leaving that, we don't want games here. Okay. So that's what sharding is. Basically partitioning a large huge database into smaller, more manageable shards. Now you tell me which will be more easier to handle and access, a huge database or small many manageable database? Yes, obviously more small manageable databases, right? That's why companies use sharding. Sharding is basically used at the company level. Now, when we say that the company is using sharding, we say it in a general term, but we do not specify which type of sharding. It is two types, horizontal and vertical. Sorry for the spelling error here. Nevertheless, horizontal sharding is nothing but it is splitting a table into multiple table containing rows. Horizontal means on the x-axis. Now take a imagination that x-axis relates to rows. That's horizontal. And vertical sharding nothing but splitting a big table into small tables which contain columns, also known as different schemas. Okay, so that is as far as sharding is concerned. That is as far as sharding is concerned. Moving ahead on to the last. So I'll explain you using the picture. Suppose we have a database which is labeled user, which contains a main heading of user table. Under that comes S number, S name and S age. Basically this what does sharding do? It separates each of the data. As you can see, 1 to 2 is separated here and 3 to 4 is separated here. So this is called a horizontal sharding. What? Horizontal sharding, as it is splitting the table into different rows. These are called rows. Horizontal is rows and verticals are columns. So here it's separating a huge table into two manageable smaller rows. One more here. Now suppose I have a database ranging from the letters A to Z. I'll divide them into three parts. A to F, G to S and T to Z will be the last. With this we come to the final part of database optimization technique for this video. I will be making part 2 and part 3 as I previously mentioned, where I will be covering from number 6 to number 8 in part 2 and number 8 to number 10 in part 3. So stay tuned for those videos too. Replication. Now replication, as we know, that it's nothing in lame terms, we say it's copy paste. It's control C, control V. Control C is for copy, control V is for paste. But in technical terms is where optimization technique where database data is copied and maintained across multiple locations. Like suppose I say I have location 1 here, then I have location 2, then location 3 and then location 4. These all locations are connected to my big database X, Y, Z. Ignore the handwriting, I'm using a mouse. So yeah, why is replication used? Basically I have this big database. I'm copying values of X onto 1, I'm copying values onto Y and pasting it there, and I'm copying values of Z and pasting it onto table 3 and 4. Basically with that helps improve data availability, accessibility and fault tolerance. Now what do we mean by fault tolerance? Fault tolerance is nothing but is nothing but if there is a fault in the database or in the system, it tolerates, the replication tolerates the fault. So it just copy pastes the value as it is, does not change anything. Further, it also allows applications to access data from different locations, minimizing network traffic. As network traffic will be decreased since you have multiple locations from where you are accessing the data, not just only a single location, which also enables for continued operation even if one location experiences issues. As since you have many locations, if one experiences issues, you still have the others at your disposal. Now, what are the benefits of replication? When we say replication also has benefits, we say a coin has two sides, heads and tails. Same applies here. Replication has benefits such as improved performance of the database and the computer or the system in general, and enhance availability of the data. So this is example of data replication process. Suppose I have a user, say you're accessing the app of YouTube, which has a server, and that server has a database. To reduce traffic, to reduce network traffic on the database, the IT head has replicated this same database into 3 different databases, where your data which is on the app, which is stored on the server, and that server's data is stored on the database, gets distributed into 3 different databases. Same here, we have 3 users whose data is on the server, which has a primary database which contains all the 3 users database. But this primary also has a replica. Some people might ask, why do we need a replica? Well, the answer to that question is that in case if the original database is damaged or something goes wrong with the original database, we still have the replica of the original database, nothing but the exact dicto copy of the original database. So that is as far as your replication is concerned. I hope you guys understood what are the 5 methods or the 5 techniques up till what we saw in this video. The further 5 remaining I'll be splitting into 2 parts, as I previously mentioned, to part 2 and part 3. So for that, stay tuned, and once this video is uploaded and once you guys see it, I'll also attach the PowerPoint presentation of this which I'm presenting into the description. So if you guys are interested, you can comment saying #PPT, then I'll put the link to it in the description. So that is it for this video. Thank you, and stay tuned for part 2 and 3, which will soon come. Thank you very much.